All right, welcome to day 6 of FOP. Last night we were working on the Python crash course. We got pretty close to the end. I think we had one more lesson before finishing off and going over to class and objects. Before we begin, do you guys have anything that you guys would like to discuss, cover, or any questions that might have arisen throughout your day? Okay, all right. Uh, yeah, so last night we got up to mutability and immutability, and then we stopped at count letters dot py. So we didn't have enough time to uh finish that or even started count letters dot py. We got okay, here we go. All right. So we're gonna start off today by doing a quick little assignment from yesterday, and then we'll move on to classes and objects, which will take the majority of the remainder of this week. Uh, so your assignment is going to be to write a function named count letters that's going to take a parameter, a string, which should return a dictionary that tabulates how many of each letter is in a string. The string can contain characters other than letters. That's going to be one of your edge cases. Ensure you're aware of that. But only the letters should be counted. The string could even be the empty string, just open and close parentheses. Make sure you guys take into account the lowercase and uppercase versions of the letter. If you guys remember from yesterday, uh, discussing the dictionaries and the different methods of using it, ensure that you um, are aware of how to instantiate a dictionary, the syntax for it, adding and deleting things from there, as well as looping through your dictionaries. Okay, we'll take about mm, 10 minutes and then we will continue moving forward. Go ahead and try that out. All right, let's go ahead and come back. Um, I'm going to share my screen. All right. So we have the assignment. We need to create a dictionary that's going to take a string. Uh, that can be of anything, whether it be numbers or it can be capitalized or lowercase letters. We need to parse through the string itself and then separate it into a dictionary while counting the amount of times it appears. So we're gonna go ahead and define this function, define count letters, and it should be able to take a string. We're going to go ahead and declare an empty dictionary, which we're going to use to count all the times it appears. Is going to be called count dict, whatever, no biggie. Um, yeah, so we're gonna have the empty dictionary, and now we want to access all the letters within a string. So we can go ahead and start a for loop for letter and str. We want to do something. All right. So we know that they can either be capitalized or lowercase. So we're gonna have to format it. And we also know that there's a possibility that we might actually run into um, numbers there or letters that are not letters, right? They might be numbers. So we want to check if it's in if it's a letter or not. So we can do if uh, letter dot is alpha. So what it's gonna do is it'll ensure that it's not a number, right? So the S alpha is one of the methods that Python has, and we can actually check that out real quick. Right,
It
so,
says we're not supposed to use that though.
oh, okay, really?
Yeah, it says, we haven't been taught it, don't use it. At the very bottom. And no, we haven't covered is alpha, the
Very
very
last.
bottom, the very last line.
Okay, all right, so if it's not, let's see, then there's other than letters, but only the letters should be counted. The string could even be the answer string just, okay. Well, if length of string is equal to 0, or if string is equal to, then we should return something, right? Uh, return, just return counted, right? So we'll take care of the empty string. So the string is empty. They just return counted, and it should be empty because there is nothing in there. And if it's not empty, then we want to do the rest. So for letter and string, how can we do this? Maybe if we try to convert it, what do you guys try for yours?
I could show you what I got. I think I got a pretty clean solution, but up
Uh,
to you.
sure, go ahead. You can show us.
Right. Let me share. So
Yeah,
my first thought was gonna be use a regex, and I probably would if this was JavaScript. Are you seeing my screen right here?
Mhm.
Okay. So I found that there's a Python module called RE for regular expression, and the documentation was a bit much, so I decided I was just going to solve it in the manner that I'm about to cover. So essentially, very first thing I did was I changed the entire string to uppercase just to make it easier to handle. I made an empty dictionary called letters, and then since we can't use is alpha, I did this approach. So for character in the string, if the character is in, and I just made a tuple with every letter of the alphabet.
Good, good.
And then I define the key value pair of what that letter is with the count that is in that string, and then I returned letters. So here I put in a really kind of cryptic looking hello world, but just with a bunch of capitals, lower cases. Down here, 2 H's, 2 E's, 4 L's, 3 O's. There's no space captured there, as I understood the instructions. I wasn't supposed to track that, but that's the way I did it.
Sweet. Yeah, pretty solid, man. Uh, I guess I didn't want to hard code A through Z, but hey, good on you. Yeah, half the time I
Can you
don't look at the assignment, so it takes a while for me to catch up to every single lesson and assignment we have on here. So I tend to forget the rules for all these. So I do apologize. But regardless, pretty good solution. Awesome. I like the tuple. If you didn't use the tuple and you use a list, what would you have done? What would the if else statement would have said?
So actually, I tried both, and it worked either way. I went with tuple because in theory it's faster.
Yep. Good stuff. Awesome. Yeah, so quick assignment. Awesome. 10 minutes tops. And now we actually get to move forward on the cool stuff, which is going to be your classes and objects. This is going to be the heaviest part of Python. So that concludes lesson 7. Now we're going to go into classes and objects. So what's a class? Right, so think of it as a factory for creating a new object. I like a better definition of a blueprint, right? So a blueprint or a recipe for building something, right? It's a way of organizing your code and it's a way to build other versions of what your blueprint is trying to create. A prime example here is your little car class that you see on the right side. So your default or like the parent class is the car class. This is
Check your slides. Yeah, your slideshow's
I'm
not
sorry.
on.
Thank you.
Gotcha.
Awesome. Yeah, so we see here on the right, we have a small little diagram. We have the base class, right? The parent, which is the car class, which holds different types of attributes like the color, make, model, and fuel type. And this is what the blueprint is. This is what every other car that's going to come after is going to be based off of, right? It's a blueprint, technically what we like to consider a class, right? And from that blueprint or class, we're able to create objects of it, right? So the blueprint is the class. And then when you actually create something out of it, that is our object, right? Not to get confused with JavaScript. I know they use very similar syntax. JavaScript we like to call like objects or like your dictionaries. In Python, objects are it's very similar to like creating a variable or creating something in actual like instantiating something, right? In code, it is a thing, if that makes sense, right? So the object here, we see three different versions. We see a yellow object, an orange object, and a blue object. All three of these received the blueprint, right? And which is what they were created from. So every single one of these has a color, the make, model, and the fuel type, right? That is the standard base foundation of what the car should be. Well, so when creating this object, every single one of these cars used the blueprint from the car class to create itself, right? And here we see that they all have their own. One is yellow, one is red, one is a Mustang, while other is a Golf. One uses gasoline while the other uses hybrid, and one is diesel, right? So although these three are different, they all have something very similar. They all derived from the car class, right? They were all made using the exact same blueprint or formula or instructions, whatever you want to call it, the recipe to the car. That is what a class is. Class objects can be used over and over again, so it's also a way of keeping your code dry, which is an acronym we like to use called the don't repeat yourself, right? That's the cool thing about coding is typically we want to avoid repeating ourselves. If we can code it once, why not automate it and make it easier for the future, right? So we tend to write code using the dry method, right? Class syntax. The class keyword is used to define a class, very similar to the way that you define a function. You use def. Here, you're going to use class specifically, right? Typically, your class name is going to be capitalized. So the name of the class should start with a capital letter. Functions that are part of a class are known as methods, right? Think of it as a function that your class can do, right? But when in the spectrum of a class, we call them methods. They're technically just functions, stuff that your class or your object is able to do, right? Think of back to the car, right? The class itself, it is a car, right? The method or the functions that this car can do can be something that's turn on, right? If it was, let's say, the class of a dog, one of the methods the dog can have will be bark, right? You can create a function called bark, and then you would print bark, bark, right? So it is a function that your object can do, or in this situation, a method, right? Functions that are part of a class are known as methods. The init method is automatically called by Python when creating an object of a class. So when defining a class, the very first method that needs to come is going to be the init method, right? As seen here. The init method is what your class uses to create itself. These are the instructions of it, right? So here we have the declaring the class pet, right? And then the very first method is the init method. This is where you're going to put all the attributes that go to your class. This pet should have a species and a name. right? So whenever you create a pet, it's some type of species and you're giving it a name. So to initialize that method, you use what we call dunder methods, right? Dunder standing for double under, which is why this init method has two double underscores to the left and to the right with init in the center, right? This is how you declare an init method. Init standing for initialize, right? This is a method that the class uses to kind of boot up, right? It takes the information within the init method to create itself. The parameters that the init method takes are going to be the attributes that you want this class to have. The very first parameter it will have will be the self method, along with every other method that you're going to have within this class. It uses self to refer to itself, right? Self referring, or essentially it is saying I, right? I am a species in a name. That's just the syntax. Don't ask me why. That's just how Python reads itself. It's the class, it needs self to know that it's referring to itself, right? So when you declare your methods, the first parameter that goes in there is going to be self every single time. Every method or every parameter afterwards will be its attribute or whatever you want to use within that method. So we see define init, it takes parameter self, and then afterwards we start declaring the different attributes it's going to take, one being species and the next one being name. Now, once you actually have the attributes or parameters or arguments you want to give your method, then you're able to use them. To use those methods, you have to use the self dot and then the name of whatever you want to use. Ignore this underscore behind this. I'll explain that in a second. Typically, it should just start with self and then dot and then whatever you want to call. Essentially, it is saying here on this first line, my self or I dot species, right? It's trying to grab the species attribute is equal to species. So you're essentially creating a variable here and assigning it the parameter that you are passing in. Does that make sense? Right? Because it's a method, it's a function. What does functions have? They typically have some form of like local scope, right? So they only have access to the stuff that you give it within the arguments or parameters. So if you want to assign a species into a variable, then you have to grab it from here. So that's what it's doing. It's doing self dot, ignore the underscore, species is equal to species, and the same thing with name. Make sense? The underscore, which we will discuss later, actually we can discuss it now briefly, is a method of essentially encapsulating the information from the class. And it'll make more sense later, right? Essentially, whenever a user is trying to use an object, you do not want them to have access to certain things within the class where they can change it and therefore break everything. The underscore between the self dot and the name of whatever variable you're trying to declare is used as a way to keep them from accessing it, right? So typically when we try to access stuff, we use the name of like the dictionary, or in this instance, the name of your class, and then you use dot notation, right? Kind of like when you try to access something in a dictionary, you use like dot notation or bracket notation, and then you call what you want. By adding this underscore within here, you add some level of security, kind of, where you do not allow them to directly manipulate the data. The user is going to try to naturally grab the name of the class dot species and might try to change the species of that class, but it won't be allowed to because in the code you added the underscore. Does that make sense?
So you wouldn't get a syntax error if you left it out, but it's best practice to have it as shown, right?
Correct. You will not get a syntax error, right? Typically, like you can have underscores in your naming convention, right? We see it whenever we use snake case. So there's no syntax error, but we add it as best practice whenever we're trying to privatize a specific variable within our class, right? It's not something that was intended to be done, but if you have any kind of experience with languages like Java, right? Typically Java allows you to privatize your variables. There's a way to do that. In Python, you don't have that, right? So it's kind of a workaround that developers have started to use to try to privatize certain attributes or variables within your class to keep people from messing with it. It's not something that's like was built into it, but we start doing it as a way to try to add some level of security to keep other people from manipulating these variables. Does that make sense? That's why that underscore is there. Because typically when we try to access stuff, we use dot notation or bracket notation, and people don't tend to think I'm gonna add a underscore before it, right? So yeah, it's like an informal thing that we
Shouldn't
do.
it be double underscore for private? And like
Like I said, it's an
single is
informal thing.
protected.
It's a informal thing, so you can do either or, right? But we're using the one underscore here. Cool. All right, moving forward. The init method itself. The init method does not need to take parameters for every data member, right? It depends on whether it will always be initialized with the same value. If what you call it? If you remember, my bad. That's not what I meant. I was getting sidetracked. Yeah, so we see here on the right side, we have the non-customizable robot, right? The init method does not have any type of parameters given to it. That means whenever someone tries to create this robot, they don't have to add anything within the parentheses. It by default will always have these forms of attributes, right? So this will always have sensors, actuators, name, and state. As you can see in this code, it's not, you can't really change it whenever you declare it from here, right? So whenever you create this robot, if you try to put anything within the parameters, it's not gonna do anything because when you declare the self.sensors in your init method, it already has a default of having this every single time you create it. Does that make sense? Right, so it does not need anything as the parameters. You can, if you want to, be able to customize it just like you saw on the car, right? If this class was in code, they would probably take the color, make, model, and fuel type as parameters, so you can format them every time you create that class. Here we see one that is customizable. It has sensors, actuators, and name. And we see here the values that's being given to these variables is being taken from the parameters set in the init method, right? Initialize an object while accepting parameters and using them to initialize. Self refers to the object itself as in I, right? As mentioned before, it's just talking about itself. It's just the syntax of how it's written. Instantiating a class, i.e. creating a pet object. So we saw before the little code snippet from line 1 through 7 of the actual declaration of the pet itself. Creating the blueprint, the class. And then when you actually want to use this class and create an object, we see here we name a variable called pet1 and pet2, right? They're calling the pet class. And then within the pet class, they're adding the parameters that the class takes, right? It's supposed to take a species and a name. And that's how they do it to instantiate an object. They call the class name, pass it the parameters. This is a capybara, however you say that, named Beatrice. This is a kangaroo named Joey. That's funny. But yeah. And then they're able to print out 12 and 13 here on line 12, 13. They print out the name. This isn't typically how you want to call the names, right? You want to use just a dot name, but he did it for a reason, and I'll explain to you why in a bit. But they print it out, and you see here it prints out the name of that object. Cool? What are these objects? The class objects that are made are just containers for storing data and functionality. These objects have properties like name or species, but they can also have methods that do things. Remember, ultimately, this is a tool for organizing our code, right? So as mentioned, it's storing data and functionality, you're creating something that can do stuff and has different attributes. It doesn't have something as simple as a pet. It could be different things. You could create a user, right, that takes name, passwords, emails, right, has the ability to do different things in your application and whatnot. Private data members, right? Back to what I was talking about. Some languages, like Java, have a keyword private that means certain data members or methods can't be accessed from outside the class. Python does not have such a keyword. So the convention is to start that data member of method with an underscore, right? As mentioned before, we have that underscore right after the self dot to add some level of security to it. Accessing private data members. So if you're not supposed to call the data member directly like this, where we call the name of the object and then we use dot underscore name, then how do you do it? Well, we have something called getters and setters, right? So notice in our bank account class that we have specific methods that are set to, that set the values of certain data members, right? Here we have the bank account. Here's the init method. And we see here on both of these variables, the account ID and balance, they both have an underscore before their name. This is because we're trying to privatize this information. They shouldn't have access to your account ID. No one should be able to just directly manipulate this specific object or whatever bank account this is. But what if we want to see what the account ID is? We should be able to see it and grab it, but not manipulate it, right? So how do we do that? Well, we have what we call getter methods, right? Get methods. Here we see a fine example of a getter method. We define get account ID. It's just a function. And what does it do? It returns the self dot underscore count ID. So this will directly return whatever ID this is. So whenever someone is using this object, instead of them trying to call the count ID directly, they will call the function. So it would be like bank account dot get account ID, and it should return to them the account ID without them directly trying to access the data members within the init method, right? The method get count ID will do that legwork for you. Does that make sense? All right. Now, if they want to change it, and it should be changeable, you can do a set count ID, right? They shouldn't access directly. You usually want to create a method for them. So it's very similar to the getter method, but instead it changes it something. It doesn't return anything for you. You can if you want, but it should directly manipulate the init data. All right, so we see here self dot underscore account ID is equal to new ID, and that's passed in here within the parameters. You set that as one of the arguments for it to be given. We also have methods that can get the value of certain data members as well. That's the getter methods. This idea is important because it gives more control over who can access the data members. Printing objects of a user-defined class. Printing this kind of object returns the class it belongs to and it addresses in memory. Not very helpful. What does that mean? Well, if you try to print, right, that you see here on line 11, they created a bank account object, right, and assigned it to the variable bank account 1. And then they try to print the object itself. But what does it return? It doesn't return a name. It doesn't return the information. It returns this weird hash, right? It says underscore main bank account object at whatever, right? Unreadable code. It returns to you the location of where the object is stored. That doesn't really do anything for us. Later in the course, we will cover how to redefine. Yeah, so I'll get to it when the slides come up to it. But there is a way to change that. So if you want to be able to print something specifically, let's say whenever you print a bank account, you don't want it to return to you this weird unreadable code that does nothing for you. You want it to return to you, the name and the account ID. There's a way to be able to manipulate this function, which we'll get to later. Objects everywhere, a nice little meme, just so you guys can enjoy. Cool. All right, taxicab.time. Let's walk through this one together because it's gonna be the first time that you guys do this. I believe mine's probably filled out here. Yep. Let me open up my empty one. All right, CD of the P, CD let's in. Okay. All right, so we're gonna write a class named taxicab that has 3 private data members. Make sure you guys code along with this, okay? For best effects. So it has 3 private data members, one that holds the current X coordinate and one that holds the current Y coordinate, and one that holds the current odometer reading. An odometer reading simply measures the distance a car or bicycle that has traveled by keeping track of how many times its wheels have turned. So if you travel 1 unit left and then 1 unit right, you'll be back where you started, but your odometer will tell you that you've traveled 2 units. All 3 data members should be updated as needed, so they are always current. Okay, so the class should have an init method that takes 2 parameters and uses them to initialize the coordinates and also initialize the odometer to 0. So let's go ahead and start putting some code up here. So we're gonna do class taxicab. The first method we're gonna do is going to be our init method. So we're gonna do define double underscore init double underscore open and close parentheses. As mentioned before, the first variable is going to be the self variable. Now, it should have 2 other variables within the init method. One is going to be the X coordinate and one is going to be the Y coordinate. So we're going to do X coord and Y coord. So we can go ahead and declare the X coordinate self dot underscore because it's a private data member. Coord is equal to X coord. So we're saying, hey, I want you to give myself an X coordinate. Where do you want to grab that data from? Well, from the parameter that's going to be passed whenever you declare this taxicab. Same thing for the Y coordinate. And now we're supposed to have a third variable or a third data member, but it's not supposed to be given within the arguments or parameters. So we can just declare that ourselves. So we're gonna do self dot underscore odometer is equal to 0, right? A brand new car, a brand new taxicab should have 0, right? Hopefully. The class does not need any set methods, so we don't need any setters. So we know that's out the window, but you probably will need some get methods. It should have a method called moveX that takes a parameter that tells how far the taxicab should shift left or right. And it should have a method called moveY that takes a parameter that tells how far a taxicab should shift up or down. Well, let's focus on the X one first. So we're going to do define moveX opening close parentheses. We're going to give it self as its first parameter. And then we want to give it some kind of number, right? This is going to be how many times it's going to move to update our x coordinate. We can call this new x. That parameter is what we're going to use to update our x coordinate. So we can do essentially, if you think about it, it's almost like a setter method, but not really. We're moving, so it has to update the x coordinate. So we can do self dot x coord plus equals whatever new x is. Right? This will be the new location of where our x coordinate is going to be at. Next, we want to do the y. So define move y, passing self, give a new y, and then once again manipulate our y data member. Cool. Now, what are we forgetting? Well, we've moved, so that means our odometer should have shifted, right? So once we move these bad boys, we should probably update our odometer as well. So going back to the move x and move y method that we gave, we're going to do self dot underscore odometer, and we're going to do plus equals, and let's do absolute for whatever the new x was. I think absolute will probably be the best way of doing this. Right? We don't want to do what the x coordinate is, right? Because that's not going to tell us anything. We want to know how many times it's going to move. So we're going to use a new x argument that's going to be passed in. And in case it's a negative value, we'll use absolute to give us how many times it moved, regardless whether it was a negative or positive. And then we're going to do the exact same thing for move underscore y. Cool, cool. Now, we also skipped over a step. The class should have get methods for each data member: get x coordinate, get y coordinate, and get odometer. So typically your getter and setters, you want to put those right after your init method. So we'll do it up here. We can do define get x coord, taking self, no other argument, and it should just return the self dot underscore x coordinate. And then same thing for our y coordinate. Takes in no arguments, but it will return to us the y coordinate. And then last but not least, the get odometer. Return self dot underscore odometer. Cool. Okay. Now, our taxicab now has its little blueprint. It has data members, and it has some functionality. We're able to move up, down, left, right, and update our odometers. So we're gonna go ahead and create a taxicab object. So we can call this my cab. We're gonna call the taxicab class, open and close parentheses, and you already see right here, it's supposed to take two arguments. One's going to be the x coordinate. Let's say it's going to be at coordinate 10 for x, and at coordinate 45 for y. And what happens if I do my cap? What do we print out my cap? We see here the object exists, right? It's giving us that little hash, so I know it exists. We're good. Let's go ahead and print out my cab dot get X chord. Not like that. Oh, my bad. There we go. It's a method, right? In other words, it's a function, so don't forget the parentheses. So my cat dot get X chord, open and close parentheses. Nothing goes in there because we saw it just takes self. That's standard. It takes no other parameters, and it returns to us 10, right? The X coordinate that was set. We could do that as well for our Y, 45, and then we can try to use the odometer to make sure it works. Odometer, and it is 0. Now, let's go ahead and move our taxi cab. So we're gonna do my cab dot move X. Let's move it to negative. We'll do 5. We'll do positive for now. Let's go ahead and move our Y 10 units, and then I want to print my odometer. And we see here the first printout is 0, right? Because our odometer starts at 0. We moved it 5 times to the right and 10 times upwards for a total of 15 movements. So our odometer shifted, and we can see here on line 29 where we printed out, it returns 15. All right, therefore it's reflecting the changes. Now, what if we add -5? It still gives us the 15 because it moves 15 times regardless. But is the X reflecting? Let's do print my cab dot get X coordinate. It's working. What if we do -25? Cool. Yeah. Pretty standard stuff. Cool. Any questions so far?
Yeah, I have a quick question.
What's up?
What if you wanted to, are you able to create different initialized functions that they could, like say you have a different odometer, say your odometer is already at 50, but if you don't have that, then it defaults to 0. Is that possible? Or do you have to have just one initialized function?
Wait, what do you mean? 2 odometers.
He's
No.
saying, can you set a default value if there is no parameter passed into the initialize
Yeah.
function?
Here, let me see if I sort of just have it real quick. See if you can see this. Can you see that? So this right here, right? Like a second initialized function, if someone decides they want to throw in the odometer.
I believe you can. It's part of polymorphism. I forgot how to do it.
Oh,
Let me do some quick research.
yeah, I mean, I tried it and I'm getting this error here. And so that's why I was asking a question. What's that?
Oh, self. Yeah, see it? It's like odometer.
Oh, that? No, I still get the same. That was a good catch, though. Thank you. But one required positional argument odometer. Oh, because when I called it, I didn't do. I did 0, right? Yeah, and then So I have to add it because it only takes the second initialized function, I suppose, then. Because whenever I try to initialize it with just the x and y, I get the issue. I mean, if this is something else, would you say polymorphism? I can just read about that. You're muted.
Hello?
Yep, gotcha.
Polymorphism is a little bit different. It's technically like overriding but that's more for child classes. So there is ways to override stuff, but you would take what's up?
Yeah, I think I don't know, but I think I can I kind of guess what he's trying to get at. If I can show my screen about, maybe this is it.
So yeah, you can go ahead and share your screen. So we'll get to it, Cody. So there is a way to use a class to create a subclass, right? Which is still not what we're talking about yet. It's a little out of scope right now. We will get to it. But essentially, there's such thing as parent classes and child classes, right? So let's say you want to change something in the data members, you're able to do that, right? You would use a parent class as a default, and then you would create a whole new class, get like a child, and then you can override some of the stuff that you got from the parent, right? That's called polymorphism. And which is the cool thing about classes, which we'll get to later. But that is an option. But you won't be able to directly change that from the parent class unless you add a setter method. You would have to create like another subclass of it. Does that make sense?
Okay, yeah.
Oh, so maybe like what I'm doing is a little wrong. So in the initialize method, I gave OD a default of 50 here, and then I set the odometer to the variable that's passed in. So if you don't put an OD when you initialize it, it'll just go to the default. So it goes to 50 because you put
So
a default there.
we'll get to that in a bit too. That is still part of the class. I like y'all's enthusiasm, but yes, you are able to give default values there. You can do it either in the argument or in the actual data member itself, like you guys saw earlier, where they created a class that wasn't customizable. They set the parameters to empty, right? But they still gave them data members that were presets. So the difference between those is that if you do it the way that was shown in the slides previously, you can't change it from whenever you declare it, right? Because there's nothing to add into the parameters. The init method would set to take no arguments. So therefore, the data members within the init method were hard coded in. If you do it in the manner that Mikhail just demonstrated, you can still manipulate it yourself, or if you decide not to add an odometer reading, it will default to something. So both are ways of doing it, and both have their pros and cons. Cool. Any other questions besides Cody?
Good. Yeah, thanks. That answered it. Appreciate it.
Yeah, thanks, Mikhail. I appreciate it. But we'll get to it in a bit, all right? Thanks for the enthusiasm. I was trying to find what you were trying to talk about, but I see what you're trying to get at with the polymorphism. We'll get to it in a bit, but hopefully all that answered your questions. Moving forward, this is gonna be for you guys. All right, class student practice stddev.py. It's a bit more challenging, so hopefully you guys can knock it out of the park. It's 6:30. Let's take a 10-minute break. Come back at 6:40, and then upon returning, start on the assignment, and we'll get about 15 minutes to try it out. Cool. I'll even break you guys into some rooms so you guys can try it out, and I can bounce around left and right. Cool.
Which one are we working on?
stddev.py.
Okay.
But first and foremost, do take a break, 10-minute break. And then upon your return at 6:40, I will open up breakout rooms, and then I'll bounce back. Cool. All right. Did it go good? Cool. Let's go ahead and walk through this. It looks like you guys are really getting this pretty quickly, which is good. I tend to have a lot of people having issues with it. Okay. All right. So write a class called person that has two private data members, the person's name and age. It should have an init method that takes two values and uses them to initialize the data members, right? And it should have a get age method. Cool. So we're gonna go ahead and create our class person. Create our init method with self. It should take a name and age. Private data members, so we'll do self underscore name is equal to name. Give our age. And we want to get our age. A getter method that returns the data member self._age. Cool. All right, pretty straightforward, right? And then we're supposed to write a separate function that's not part of the person class, right? Called std_def that takes as a parameter a list of person objects, right? And returns the standard deviation of all their ages, the population standard deviation that uses a denominator of n, which uses a whatever. Too much to read. Anyways, so return the std_def. Cool. We're going to go ahead and create a handful of people for the sake of time. I'm just gonna go ahead and copy and paste this here. This is going to create our objects, right? We have three objects here: Human, Mercedes, and Beatrice. I don't know who names their kid Mercedes, but all power to them. And then we're going to define the std_def function, right? So def std_def, and then it should take in here a object list, right? And now we have to do something, right? To calculate the standard deviation, you'll need to take a square root, which you can do just by using yada yada, right? So some math. But let's check out what this standard deviation actually is. There are two types of standard deviation calculations. Population standard deviation looks at the square root of the variance of the set of numbers. It's set or it's used to determine a confidence interval for drawing conclusions such as accepting or rejecting a hypothesis. A bunch of mumbo jumbo. Now, did you guys use this right here? Is this the one you guys use, the formula?
Yes.
Try to.
Okay, so we're gonna use that as well. So first, we're gonna have to calculate the mean, simple average of the numbers. So we essentially need to know, we have to add up the ages of all our people and then divide by the amount of people added, right? Simple math. So we want to grab the mean. We'll keep it like this for now. Essentially, let's say we're gonna want to do, we have to get the age, all right? And luckily, we defined a method to get the age. And then we also have to get the mean. So we'll do for person in object list, let's grab the person's age. So person dot get age. And then we want to add it on something so we can declare a separate variable called total. We got to get a total amount sum of all their ages. and then we can add it to the total. So we can do total plus equals person dot get age, right? So as we loop through our objects of people, we're grabbing their ages, adding it to the total, and then afterwards we can do mean of ages is equal to the length of object list, or I guess total divided by the length of total object list, right? And that should return to us our mean. Now, let's check out the next part. For each number, subtract the mean and square the result. For each number, subtract the mean and square the result. What the heck does that even mean? For each person, subtract the mean. English is my first language or my second language. Someone help me out here. What are we supposed to do? What kind of math is this?
I mean, it's just saying for you have that the mean. You're taking each individual age and then subtracting that. So say all the numbers are 40, 45, and 50. The mean is going to be 45.
Okay.
You take the first one, 40 minus 45, square it. 45 minus 45, square it. 50 minus 45, square it. Add those together. And that's what that means. Square each deviation, then add them together. So that would actually be
Okay.
50,
I see.
right? 'Cause yeah.
So subtract the mean and square the result. Calculate the mean of those squared differences. List is the variance. All right, so we can do. We have to create a new list. List of differences is equal to empty. Then we can do for person in object list. We will do person dot get age. And what was that? So we have to grab their age, subtract the mean, minus mean of ages, and then square the result. And then when we get this, we want to add this to our list, right? So we could do new result.
I think that's square root you're doing, the 0.5, 0.05.
Square the result, square root. Is it square or square root? It read me say square root.
You square that one.
Yeah, the square root is comes down later.
Okay, thank you. To the power of 2.
So will that square the mean, or will that square the difference between the age and the mean? I think you need to put the age and the
In
mean
parentheses.
in parentheses. Yeah.
The age and the mean in parentheses.
Yeah.
I
there
see.
you
Okay. And then square the result. That gives us the new result. Add that to list of differences. Okay. So now we have a new list of differences. Take the square root of that. Hey, what? Calculate the mean of those square differences. Okay, I see. Now we have to get the mean of those. This is the variance. So, for means of list, no, for new results of list of differences. Oops, in. Now I'm going to go through the new list of differences. We want to add them up. I guess we would do new total.
So I don't think your list of differences, you're appending them, so you're making another list. You actually just have to add them. You don't
Ah, that's
Yeah,
smart.
yeah, you don't need the list of. Yeah, you just add them as you do it. So new result equals, and then just. Yeah.
Yeah. Quick
that way you
maths. Quick maths. Yeah. So we can just do whatever this returns. We say sum of differences.
Sum of the differences squared. Yeah. Squared. But
It's fine. Well, because this is it gets all the results, right? Everything's already squared, whatever, and then we're gonna add it all up and then just divide it by the length of the object list, right? Is that what you guys getting at? So sum of
Yeah.
differences. Essentially, this will be sum of differences, and then we can do sum of differences divided by the length of object list. So that's the variance, telling me those square differences. And then take the square root of that to obtain. So we should be able to return some, or we do new mean. And then return new mean squared root of that. Right? Take the square root of that to obtain the population standard. Look good? If our math is correct, it should work. Let's try it out. And then I want to compare answers with you guys. Did the rest of you guys finish this?
I finished it.
I can tell you what the module got too. So
Yeah,
what
I
is
was
this?
trying to figure out the standard deviation for the most.
You guys get this too?
I got 24.501.
What'd you get,
Supposed to be,
Mikhail?
it's supposed to be 20.00. I use the calculator online to check it.
You guys are cheaters, man.
It's definitely in the 20s because you're looking
Yeah,
at like a 73, a 24,
I
58.
I just checked it.
yeah.
Okay, well, where are we going wrong here? What do y'all think? And this isn't even a code issue. This is more of a math issue at this point. So let's break it down, right? All right, so calculate the mean of all the ages, right? So we got all the ages. As we grabbed them, we added to the total. And then we got that total and we divided it by the length of the object list, which is 3. Maybe if we do lower, you think it will change it? It did not, no. But yeah, so we have the mean. We got step 1.
Yeah.
Correct?
the mean
Everyone with me
number,
still?
Yeah.
And for each number, we want to subtract the mean and square the result.
I think you
So
put the exponent at 0.05, not 0.5. That's totally different. It should be half, right? For square root.
you are right. Yo, sweet, dude. Good catch. I also only have a high school education, so that's what you get. Cool. All right. Who said we were wrong? Anyways, good stuff. Was that good? Did you guys learn something while doing it? Anyone have any questions about the assignment? Not about the SCD dev, but anything involving the code itself. The classes, methods, functions. I don't care if you guys know what SCD dev is. I just want to make sure you guys understand classes and objects.
So in the like I keep hearing in the immersive gone.
Eric, you cut off for like 3 seconds. Do you mind starting again, please? I'm sorry.
Yeah, I was just saying, keeps being brought up that objects and classes are like the hardest thing most people typically get stuck on in the immersive. Is that like stuff we've seen so far? Is it other aspects of it like inheritance that I'm sure we're gonna cover? Just kind of curious Because
Yeah, I
I
mean,
feel like this group gets it pretty decently, it seems.
it's gonna be building up. By
I think the,
Friday, what's up?
I think the hardest inclusion is when you start using classes from different files and such, like the importing and the all of that.
Yes.
And then also like hashing, it gets really confusing.
So you'll start doing stuff like that. You'll have multiple classes and all types of objects. You're gonna have to open up documents, read through all have you guys ever heard of CSV files? You will through an FOP, but you'll have to go through CSV files, go through all this code, grab all this information, format it. Yeah. So it gets harder, right? We just started off, Eric. We've been at this 2 hours. All right, we'll slowly build up, right?
Gotcha, sounds good, thanks.
Yeah, no problem. So yeah, I know it's so far it's easy. Some of you guys are gonna get more than others, right? And as we start getting into more complicated things, some people are gonna struggle more than others. If you're getting it, then it's awesome. If you feel it's easy, Eric, hey, all props to you. It makes me happy to know that you guys feel like, is this as far as it gets? Then that's where we should be at, right? I like to hear that, but we'll build up to it, okay? And Zeus, I see your message. Yes, afterwards I will take snapshots of any code you guys want. Just make sure you guys let me know of what you want, and I can post anything on the Slack channel so you guys can reference later. All right. Moving forward. Anyone else at all? Was that it? Cool. All right, passing objects as arguments, right? Objects can be passed as arguments to any method because everything in Python is
Sure.
an object.
You need to share a screen.
Yes.
Gotcha.
Thank you. Yeah, so this is an abstract concept, so it's okay if it's not clicking yet. On the right side, we have here the class pet that you guys saw earlier. Being defined, it takes only a name, and then it has a get method that allows you to grab that name, and then we have a new class being declared below it for home. This one takes an owner as a parameter. It assigns it to the self._owner data member. Then we also see here another data member that's preset for every home that it comes with. You don't have to add it as an argument, but all homes come with a data member called pets, which essentially is an empty list, right? Because not every home just comes with a pet right away, but you have the option of adding it to it if you want to. It then has two methods: adopt a pet and show pets. Adopt a pet allows you to pass in an object, right? We see here on line 19, it's taking an object as an argument, and then it grabs that object and appends it into the data member pets, right? Which is essentially a list. And then on the line 25, we have essentially a getter method, right? That says show pets, which returns the list in self._pets on line 17 to showcase all the pets that this person has. Here, they only have one pet. They adopt them on line 34, and then they print the show pets, and then they get the name. The first line 36, when they print the list of objects, we see here it's a list, it's in brackets, but the object itself is hashed, right? So you can't read it, it's just telling you the location of where it's at, because you can't just print objects. But on line 37, they do some list comprehension here, where they're doing the for loop for pet in myHome.showPets. They're going through the array of pets from the data member, and then for each object they grab, they're calling the get name method, therefore printing out the method for each object. Cool? So you're able to pass in objects as arguments. All right, moving along. Cool. Creating objects of one class inside of another, right? So you're able to create an object within an object. Here on line 1, we're creating a club. It has a title, and you're able to use the get title method to grab the title of that club. And then we have another class here being declared called club association. It takes nothing as an argument, but it is immediately instantiated with a data member called recognize clubs. Essentially, it's just an empty list. And then the club association has a method that allows it to add new clubs into the association. It takes the title, and then with that title, it's creating a class or an object on line 15, right? This class itself is creating another class within its methods, creating it on the new club object. It takes the title, which is essentially the argument that the club init method says it needs, and then it's adding it right into its data member recognize clubs, depending it in there. Pretty cool. Then it also has your typical get method right here, kind of, or it's just honestly a regular method where it's able to print out all its clubs. Everyone still with me?
I don't really like how they're constantly giving us the hash. Cause I mean, is that really useful to us?
No. Let's
Why would
see.
we not take the extra step to show the string?
It doesn't have it here, but we can do that real quick. Where's that? Let's see if I remember it correctly. It should be define thunder. So return f so dot underscore name. For person in person list print person. There you go. So how do you change that? Well, it's by another dunder method, right? So just like we have the double under method in it, you have the ability to use the dunder method string, right? Essentially, it allows you to manipulate what that hash is, right? So instead of returning the hash with location, whenever you print the object itself, it'll return whatever you declare. Here, I'm able to do something like this. So name, and then print out the name, and then age, so on and so forth. So whenever I print out the object, it can print something out like this for me. So that's how you fix that, Brandon. Cool?
Okay.
Yeah. I didn't want to talk about it yet because I didn't know if it was in the slides yet, but I didn't see it. So that's why I might as well just show it to you guys. But yeah, that's how you do that, allowing you to manipulate the return of what gets printed out. Cool. Using objects of one class inside of another, I think where we call that. I don't think we did actually. So I think it's pretty much the same as before. Here we have check title. I think it's the only difference here. We have for a club object in self._underscore recognize clubs. So it's looping through the data member of the list of clubs it has. It's grabbing the object, and because that object has methods, right? Get title. It's checking if the title is equal to some specific title club, the Baker Street Irregulars. If it does, it's saying yes, that is a recognized club. Therefore, just checking if that club exists within the association, right? So you can create the class inside of it or the object, and you also are able to manipulate it if it was created through that. Cool? Yo, my dog, hold on, give me a second. My dog just turned off my monitor. Yo, get out of here. Go. Hold on, give me a second. It's booting up. He walked through the outlet. All right. So in summary, you can use objects of the same class or another class inside any method. A method can accept an object of any class as a parameter in the same way it would accept an integer or string. By default, a method will always have a self parameter, and self will reference the object on which the method was called. When a method takes an object as a parameter, you can call methods on it that are defined for that class. All right. Next assignment, line segment.py. Time is 7:27. Return at 7:37, and then begin working on it. Cool. All right, guys, let's go ahead and come back. Let me get a volunteer for this one. Anybody?
I'll show the first half. I wasn't able to finish though.
Okay, sure. Let's see it.
Is that big enough?
Yep, perfect.
Alright, so as per instruction, I started off with class point, and then I initialized the point object with self x coord y coord. Then I set the x coord to the pass variable, same thing with the y. Then I had set up the getters, although I didn't use them yet. And then, oh yes, I did. I set up the getters for the x and y coord. And then for my distance 2, I just set a variable for each point. That way I didn't have to type out self.get multiple times. And I used I think it's called an implicit return. I think that's what Guillermo called it, to basically run the distance formula. And I was able to get 19.104 and then checked myself in a calculator. And then I just got started on the second class for line segment.
Okay, yeah. Pretty straightforward. I think the hardest part was probably line 17. The remainder of the code, if you want to stop sharing real quick, I'll share myself. Will look like this. You have your class line segment where you give it 2 points, 0.1 and 0.2. You assign it like normally. And then you have your getter methods to get m.1 and get m.2. And then you have your method length, where essentially you would use the distance to method to grab the other endpoint as well. But pretty straightforward. Any questions about anything involving class and objects before we move on to the next part? I think this next one is probably the toughest one for today. And we'll take the remainder of our time here. And due to this one, I think we'll probably break up into groups of 2s to ensure that everyone has someone to assist them each other. No? Okay. Well, the next one is going to be your streaming guide.py. Let's go ahead and open that up real quick. This one's a little bit more code intensive. So you're going to have to create something very similar to kind of like what Netflix is. You can create a class called movie that has different data members like title, genre, director, and then being able to grab the data members from them. Then you'll have a separate class called streaming service that will have a name and a catalog that holds different movies that it has in that streaming service. All right, so you should be able to create movies and add it to your streaming service. And then it should have another class called streaming guide that allows you to use the different streaming services that it has. Okay. You should have some kind of code snippet here too that will allow you to test all the different code. This will be the last assignment for today, and probably the longest as well. So if at any point any team needs any kind of help, please raise your hand in the Zoom chat, and I will move my way to you guys and assist y'all. You guys don't use it often, so please do use it. If not, I'll just bounce around and see if anyone needs any help. But I'm here for you guys, so do not hesitate, please. But that's unfortunate. I like debugging stuff on camera because it helps people see, like,
Let's debug it. Help.
Okay, well, yeah, you're receiving a type error from line 54 saying that the list object is not callable, right? But the reason for that was because you had parentheses when you were trying to return a data member, almost as if it was like a function or something, but it's supposed to be a list, right? So you're just returning the wrong thing, fixing it by removing the parentheses. Very simple. Happens to the best of us overlooking stuff, especially when we're looking at a bunch of code. We tend to get tunnel vision. I myself get tunnel vision pretty easy as well as I'm trying to talk and instruct and whatnot. A lot of things going on, so it's very easy to miss stuff. So it helps to be able to do pair programming like we just did in groups. That way you guys can both see it and you have, two pair of eyes instead of one. But all right, we're gonna go ahead and move forward. I went through and did it myself since no one was asking for help. I just went ahead and did it. I already had it before, but it helps me to be able to refresh myself on the assignments by redoing it for you guys. Go ahead and share my screen. All right, so from the top, I think everything up to honestly most of it was pretty straightforward on the building of the classes. So the movie, we took the different types of data members. I simply added it on mine just to ensure that there was no weird finicky stuff going on with the typecasting, but not really necessary. So I added integer in case they try to instantiate a movie and they use like a string in there for whatever reason. But yeah, so int and then adding the get methods, get title, get genre, get director, get year, pretty straightforward and standard across the board of how we did that. When we got into the streaming services, just to remind myself of what I was creating on the data members, I added a little note here to ensure how it's built. Keys were the titles with the values being objects. Standard get methods, get name, get catalog, and then added the movie. Here's where you might see it's a little bit different from yours. I did try and accept blocks. And that's just to give me some kind of feedback as I'm, coding along and trying to run my test to see if there's any kind of issue. So here we see on adding a movie, the try and accept block, if you guys are familiar with it, you try whatever is within the try block, and if at any point throughout that code there is an issue, it stops, right? If it does not succeed, it will immediately stop and go into the accept block. It's a double-edged sword sometimes, especially when you have a lot of code in the try and accept blocks, because if there's a lot of code in the try and something goes wrong, it can be hard to try and debug it, right? So use it sparingly depending on what you're doing, because here I was only trying to do one action, which was add a movie into the catalog. I thought it was appropriate. So I did the try, which was go ahead and add this movie in here. And if it was successful, it returns movie added successfully. And then I have two accept blocks here. One is catching a specific error that is very common. It's a built-in error, which typically you see you have, like, as you remember before on the lesson involving errors, you have like type errors, syntax errors and name errors. This could have been a syntax error or a type error if I wanted to. I just put name. But I feel like it would be more fitting if it was a type error. But I mean, it probably won't do much. It's just kind of to give you guys an example how you can use try and accept blocks. It would be more fitting in other situations. But regardless, just so you guys can see a little bit of try and accept, just know that you're able to use more than just one. Here I'm able to specify to catch if there is a name error and it prints out variables not defined. Or if it doesn't catch any specific error, it doesn't work. It just tells you something went wrong. And I did that for both adding and deleting. If I try to delete something that doesn't even exist in there, it would, tell me either delete it if it was, if there's an issue with what I was trying to grab and delete. Same manner, variables not defined, or something went wrong in case this doesn't exist, that movie title. Just know that you guys can use try and accept block, right? Moving on to the streaming guide, we added the it was very simple. Just a streaming services data member was an array. Adding a streaming service and deleting it was kind of the same way. I just added the try and accept block and appended it in it. What I didn't get to debug before I wanted to close up the rooms was this. This was giving me an issue, and we can get to that in a bit. Essentially, deleting a streaming service by the service name. You want to go through all your services, find the service that matches the name that you're looking for, and then once you find that service, you want to remove it, remembering that the service catalog was essentially in the form of a list. So this required the .remove, removing the service from that list successfully. And then we went to the where to watch method. Here, we were supposed to be given a movie title to this method. And then using that movie title, we want to go through all our streaming services, their catalogs, and find the movie we want to watch and return it in some kind of format, right? And then after we find that, we just format it, add it to the list, because I don't know why it's specified to return it in a list with it being the 0 index one. I'm assuming there was intentions of finding the same movie in multiple catalogs, but regardless, I did that. And then on line 82, we return the result if result, meaning there's something in there. If not, return none. Cool. And then this code snippet here was directly copy and pasted from the README. And then we will run this. We see here the movie added successfully, deleted successfully, streaming service added successfully. All the messages I added to ensure I had some kind of feedback when I was doing stuff, so I can actually see this code. We do have an error here, which is the one I was telling you about. It stopped here. There was an error, as you see, it doesn't run line 109 and 110. Afterwards, it just kind of stops. It said there's an issue here with the way I removed it, and it said it was not in the list. I'd have time to debug it, but just for the sake of the demonstration, let's go ahead and comment this out. I can run this again, and then it actually runs line 109 and 110, which you see here, the formatted string of how they wanted it. I think I added right here. I added an extra parentheses. But yeah, so the name of the movie, I forgot what this was. The service, I think. Yeah, the service. I guess I put these backwards. This should be genre, then the service name, and then director. Something like that. I don't know. Point is, you get the idea. But yeah, so I think this was a little bit more heavier than what you've done today. Tomorrow's assignment is going to be very similar to this, which will take most of tomorrow and Friday. This is actually something very similar to what you're going to see during the actual immersive program. But this is a little bit less intensive. You don't have as many other stuff and whatnot that you have to do. But if you're getting object-oriented programming up to this point, you're on the right track. Okay? How do you guys feel?
We just made Netflix.
Yeah, pretty much, right?
The
Pretty
back
cool.
end.
But it's nice, right? Isn't it cool to see how like it all works? And how like classes are able to put things together and organize your code and build multiple things, like building multiple streaming guides, having different methods that they can do. It's
I
pretty nice.
definitely like classes the most in coding. Like I think they're honestly the most powerful, but a lot of people say to use simple objects instead. But I will say that JavaScript classes are so much better than Python classes at my current level of understanding. I really prefer using this instead of self. Self feels way too abstract for some reason. But I picked up JavaScript classes so much easier.
I haven't really messed with JavaScript classes, so hard for me to relate. I didn't even know you could actually make stuff like this in JavaScript. But that's interesting.
You could do the same exact thing with JavaScript. So
That's pretty cool. I'll definitely look into that. Anyone here have any questions about the material? No. Do you guys actually we'll save that for later. Yeah, so this is gonna conclude today's class. We have 10 minutes left on the clock, which I'm gonna open up for any kind of discussion. Let me go ahead and stop sharing and stop the